All right, our first section in this new chapter is 1.3 square root. So please remember that the square root is just this symbol right here. That's a square root symbol. And it's assumed that there's a 2 in there. We don't typically write it. Again, that's just our normal. All right, so let's talk about some perfect squares. So if I write some numbers down, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are the most common ones, but I like to throw in 11 and 12. So just some numbers. Now, perfect squares are really just taking those numbers and squaring it. Okay, so 1 squared is 1, that's easy. 2 squared is 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. So all of these guys should be things that you know. Those are your number sense. You need to know perfect squares because we're going to be simplifying radicals. And again, we need perfect squares in there in order to simplify. So let's go ahead and get started. 72. Okay. So the biggest perfect square near 72 is 81. Okay. And we just go down from there. Okay, so after 81, we can look back at our list if we need to. It'd be 64, 49, and you're just checking to see which of those go in there. Okay, so 64 doesn't go in there. After 64 would be 49, it doesn't go in there. Our next one is 36. Well, 36 does go in there, so it'd be 36 times 2. Well, the square root of 36 is 6, so that comes out, and the 2 stays underneath. And that's my answer. All right, let's check our next one. So 96. So the biggest perfect square near 96 is 100. And again, I'm going to go down the list till I find one that works. So 81 doesn't work. 64 doesn't work. 64, that'd be 8. So 49 doesn't work. All right, if I keep going down, that was 7, so then 636 doesn't go in there. I'm just checking on my calculator. All right, after 36, 25 we know doesn't go in there. All right, that was 5, so 16. Oh, 16 works. It'd be 16 times 6. All right, so the square root of 16 is 4, and that comes out. Please don't forget this negative sign that was right there, so you have a negative 4, and the 6 stays underneath. So negative 4 square root of 6. Ooh, I like number 3, and the reason why I like number 3 is both of those numbers on there, both the 36 and the 81 are perfect squares. So the square root of 36 is 6, and the square root of 81 is 9. Okay, and then the only thing that we need to remember is that fraction we always look to see if it simplifies, and that guy does. So our final answer is 2/3. All right, on number 4, we've got 2 pieces. So I'm going to simplify each of the parts. So looking at 20, the biggest perfect square that goes into 20 is 4. So 4 times 5. All right, square root of the 4 is the 2 that comes out. 5 stays underneath. All right, biggest perfect square that goes into 98 is 49, and it'd be times 2. All right, square root of 49 is 7. The 2 stays underneath. All right, so that's not so bad, but oh no, this is an issue. We are not allowed to have a radical in the bottom. Okay, so I'm going to rewrite what my answer is so far. I have 2 square root of 5 over top of 7 square root of 2. And we need to get rid of this radical. We are not allowed to have it in the denominator. So we need to multiply top and bottom by that radical so it cancels out. So we're allowed to do that because the square root of 2 over top of the square root of 2 is 1. You can multiply anything you want by 1. All right, so when I multiply on the top, we have the 2 that's on the outside. All right, and then I have these guys that get to multiply together because they're both underneath a radical. So that would give me the square root of 10. On the bottom, we have the 7 on the outside. And then the square root of 2 times the square root of 2 is the square root of 4, which is 2. Okay, so now I have a 2 on the outside and a 7 on the outside. So I'm actually going to scribble this out because 2 times 7 gives me 14. All right, and last but not least, because again, this one has lots of steps. The outside numbers 2 and 14 can simplify to 1 over 7. So really, I have the square root of 10 over top of 7. And you are welcome to put that 1 there if you want, but you don't have to. All right, let's keep going. All right, number 5, we got to simplify. We got that radical in the bottom. So like we did on the last one, we're going to multiply by the square root of 5 over top of the square root of 5. On our answer on here, we have a 3 on the outside, a 5 underneath the square root, so they stay separate, just next to each other because they were multiplying. And on the bottom, the square root of 5 times the square root of 5 is the square root of 25, which just simplifies to 5. This one's nice and easy because it's all done. Nothing else simplifies. All right, our next one. On the top, biggest perfect square that goes into 8 is 4 times 2. So that would give me 2 square root of 2 on the top. And on the bottom, the biggest perfect square that goes into 18 is 9 times 2. All right, so that would give me 3 square root of 2. And what I really like about this problem is I have a square root of 2 on the top and a square root of 2 on the bottom. They cancel out. So my final answer is 2/3. All right, what if I have to add or subtract? Well, the rule when you add or subtract radicals is they must have the same radical underneath to go together. Just like you would say 6x plus 9x gives you 15x. This guy is going to give you 15 square root of 3. Now, if the radicals don't match, you probably want to make them match so you can put them together. So I'm looking at 18, and I know that's not simplified. I know that 9 times 2 can go in there. So really right now I'm at 11 square root of 2 minus, once I simplify this guy, it's going to be 3 square root of 2. Well, 11 minus 3 gives me 8 square root of 2. All right, on the next one, I'm noticing a 6 underneath here, so I'm hoping I can get a 6 in here. So 150 divided by 6 is 25, which works out well because 25 is a perfect square. So this 150 simplifies to 5 square root of 6 minus 8 square root of 6. So 5 minus 8 is negative 3 square root of 6.